I'm putting my sci-fi hat on now. And I'm going to share today about our plans to launch a nonprofit foundation for hosting open source RISC V implementations, tools, and code. So just to be very clear, as Rick said, this nonprofit is a separate entity that we're trying to make, which is separate than the RISC V Foundation. This foundation, this nonprofit, focuses on the artifacts, the code, the actual implementations. And we're going through lots of different names, but the current front runner is Free Chips Project. Free as in the verb. Let's free chips. I have to emphasize, Sci-Fi loves open source. Sci-Fi believes in open source. Sci-Fi thinks open source is necessary to come up with a fundamentally different way to build chips, to democratize access to custom silicon, to enable mass customization at scale. We believe open source has to happen. As a matter of fact, we believe it so much to the point where we have open source the Freedom E310 chip that Jack talked about this morning. The chip up there, all the RTL of the actual chip is put in a repository. You can go access it. It's in GitHub. You don't need to talk to companies. You don't need to sign any NDAs to see the chips. Oh, so by the way, just a quick shout out. So if you want the Hi-Fi 1 board, which has the Freedom E310 chip, by December, I think you should hurry up because last time I checked, there's only like 180 boards left or something. So just a quick shout out. So the first three repositories up there, the Rocket chip, the Sci-Fi blocks, the Freedom repository has the RTL of the actual chip, as well as the FPGA scripts to map the RTL down to your FPGA development kit. We have also open sourced the board support packages, the Freedom E SDK, the Freedom U SDK. You can also find it on the GitHub repositories there. The documentation and the board schematics are also up there at dev.sci5.com. We have opened a forums to answer any of your questions while using the open source. As a matter of fact, we already have received one pull request for the Freedom repository. So we're developing things at open source speed together. So some interesting statistics of the Rocket chip generator, which is hosted at the URL. It has been forked 101 times, starred 187 times. There's about 4,000 commits which have been made starting from October 2011. This is the commit graph. Sci-Fi started around 2016, and you see a big spike from 2016. Yesterday, I have counted the number of commits, and it came out to be about 1,700, which is 40% of all the commits so far on Rocket chip. Sci-Fi believes in open source. So to kind of go through the Sci-Fi's contribution to the Rocket chip repository, which we have made as under the Apache version 2 license. We have enhanced Rocket Core. We have added 32-bit support to Rocket chip. So it supports the RV32i base with MAF standard extensions, compressed support, blocking data cache, data SRAM options are all added as open source. We have made a lot of changes to the TileLink. As a matter of fact, we have re-implemented the entire TileLink specification, which is our open cache coherent interconnect, which also supports memory mapped I/O. We will publish an English version of the TileLink specification so that everyone can go grab and use the TileLink protocol for your own SoCs. We have implemented a library called Diplomacy. It's a framework for global parameter negotiation. And some other primitives that we have added are multi-clock support, clock crossings, as well as asynchronous reset flops. I was talking to some people over the networking break, and I have realized that we have not given you a Rocket chip update in quite a long time. So just to be very clear, Rocket chip does implement external debug. I am answering a question. Second one is Rocket chip has moved away from the host target interface. It's no longer tethered. It's self-hosted. As a matter of fact, the Freedom E310 chip on the Hi-Fi 1 board has multiple options to boot from the mask ROM, the one-time programmable non-volatile memory, or even the quad SPI flash. So the support Sci-Fi has added all to the Rocket chip repository. So go crazy on it. So in parallel, we also have a sci-fi blocks repository, which has, so the rocket chip repository kind of has the core and the SoC interconnect. The sci-fi blocks repository has all the things that go around the CPU to actually build an SoC. So that includes the low-speed peripherals, SPI, UART, PWM, GPIO, even the power management unit that we implemented is also open source. The sci-fi blocks are written in Chisel and has tiling interfaces. This repository also has wrappers for the high-speed Xilinx FPGA peripherals, like the MIG DDR controller and the PCIe controller box. And this repository really shows our vision on how to make a plug-and-play SoC generator by using the reusable parts. So if you are interested in how Chisel and a modern programming language can really help you build SoCs very quickly, I would go take a look at this repository. So the third repository is the Freedom repository, which implements the Freedom platforms. This repository submodules both the Rocket Chip repository as well as Sci-Fi Blocks repository and has the top-level SoC integration glue code. And this serves as a good baseline to build an SoC with your own custom blocks. So this is kind of a vision on how people would extend the Rocket Chip with their own blocks. They would implement their own blocks as Verilog and put Chisel wrappers, or embrace Chisel and write peripherals in Chisel. And they would fork the Freedom repository, submodule their own repository there, and look at the top-level integration glue code and just put your peripheral in, and there you go. You have an SoC. So this time, we have also open sourced the FPGA scripts to map the RTL down that we have taped out for the FE310 chip onto an FPGA development board. So we have open sourced FPGA scripts for both the Freedom E300 FPGA dev kit, which maps onto the ARTI board, as well as the Freedom U500 FPGA development kit, which maps onto the VC707 board. So what can you do with these FPGA kits? Well, this is the ARTI board that you can buy at $99. You can map the same RTL that we taped out onto the FPGA. That means that the same software that was running on the chip will also run on the FPGA development kit. So that is a Arduino shield that is plugged into the Xilinx FPGA board, and the same software that was running on the chip, the Hi-Fi 1 board, will also run on the FPGA development board. This is really exciting. This is the Freedom U Unleashed platform mapped onto the VC707 with a bunch of PCIe devices running Doom. You're not excited. It's a real computer. Come on. There's USB keyboards, USB mouses plugged in. All these demos are available at the Sci-Fi booth today at the poster session. So if you're interested, I would urge you to go take a look. But then after all this, you're happy. So with this FPGA development kits, what that means is you can start prototyping your innovative ideas in hardware on the Freedom platforms mapped to the FPGA development kits running real software. And once you're happy, you can go talk to Jack to talk about how to build an actual chip. But we all know that it takes a village to make open source hardware real. So that's why today we're launching the Free Chips project. The mission for the nonprofit is to become a home for open source code base to enable faster, better, cheaper chips. So the purpose of the foundation will be to sustain and evolve open source tools and HDL code for SoC design, and to ensure all the contributions that were made to the repositories are available to the entire community, and to manage the repositories, documentations, and issues. So the foundation will start with initial contributions from Sci-Fi and Berkeley. But if this mission really resonates with you, please come talk to me. We have recruited Jen Willis, who has been building a lot of industry alliances to help out with the nonprofit launch. I would love to make an introduction so that you guys are connected. And if you have some cool open source hardware project that you want to open source, this might be a great venue. So with that, that's all I got. I'd be happy to answer any questions. Thank you. There's one question.
Question in the back?
You're applying for 501(c) status through the foundation, is that right?
6, probably.
Or
You know.
some nonprofit status?
Yes.
Have you,
Jan?
okay.
Yes, is the answer.
Have you received any pushback because it's open source? There's recently been a few articles about open source being denied such status. Open source foundations. The answer could be no.
Yeah, we don't have any feedback that that's an issue so far.
Come to the mic, John.
Yeah, as Jensip said, this is just the beginning. We haven't had any issues raised to us about that as yet, but we'll be going through, just like Rick has gone through, a lot of legal process to form it. But in preliminary discussions, nothing's been raised. Yeah, six is, so 3, there's charitable, and then there's sort of consortium group activity, and this falls into the group activity.
Yeah.
So I'm with the LLVM Foundation. We recently went through the process. We did a lot of homework. We're very careful because we heard of some of the concerns, and we were approved very quickly. So it seems that there was some concerns at the IRS, but I think they've worked through that to a large extent. That was because of other nonprofits. And that really only applies to a .3. If it's a .6, it's another issue.
Any other questions? And if anybody wants to talk about that over a beer, I'll point you to a bar far, far away from here. No, as Jen said, I've got a lot of body scars on that topic, and happy to expand on it more later if you want. That's the only question for Yensef, really? An IRS question?
Please find a tax advisor.
So I'm Sam Falvo. I'm with the Casserole Computer Project. I'm the only person part of the Casserole Computer Project. And you know, I've got this poster session that I'm going to be doing later today, which is thoroughly underwhelming compared to that Doom thing that you have here. So I'm just kind of curious, why? Like, I'm pretty sure that Kestrel is reasonably well known in the RISC V community, and people know that I've been trying to promote this as an open source computer. It's designed specifically to be a home computer. Right now it's kind of the same scope as like a 64-bit Commodore 64, but you know, if long term I want it to run Linux and BSD and stuff like that. I guess my question is, knowing that these are my goals, and that the community has been aware of it, like, I'm kind of curious. I've not received any people willing to contribute or willing to, you know, further the project along. How has your reception been towards that, and what am I doing wrong, basically?
I'm wondering whether I should give you which answer. So it's been very interesting because most of our code base is written in Chisel. We've gotten a lot of pushback actually on adapting our code and using our code, but we believe in Chisel. We believe it's a very different way of constructing an SoC, and we kept going, and it's pretty feature complete. I think with that, some people have gotten over the Chisel hump, and once they have, you know, gotten over it, they love it and they start contributing back. I think it's an iterative process, and I think having features that people care about implemented in the open source code base. I think that really has a great pull for people. But I mean, it's not super easy to have an open source community around your project. I think we have the same pain.
So yeah, I have a question. So there are for
Do you identify yourself, please?
I'm Kumarel. I work for Energis Corporation in verification of hardware verification. So I have a question on basically for hardware, like the free chips project. Basically, there are a lot of tools associated with hardware which are not free, and that bottlenecks lot of open source hardware projects. So how are you overcoming that type of a hassle?
I totally agree with that statement. That's why I really like Michael Taylor's talk today. So let me give you my take on it. I think the hardware industry should understand that if they make tools less and less accessible, there will be less and less people who are willing to do things. And that's really going to have a hard hit on the hardware industry. So that said, how are we dealing with it within the Rocket Chip project? So we use Verilator to do most of our simulations of the Rocket Chip code base. As a matter of fact, the Rocket Chip repository has regression tests using the Verilator. That's how we use Travis, just how all the software projects, all the open source software projects do their regression testing. So that really enabled us to just farm off the verification to an Amazon EC2 node using the Travis service. I think the second part is if you buy an Xilinx FPGA, you get the tools so that you can map the FPGA onto the RTL to your FPGAs, and you get at least some simulation infrastructure with that. But that is one of the things that I think the nonprofit should push on getting more tools. I think we should not stop just at the simulation tools, but also extend it to synthesis to get some timing closure back as feedback, some feedback for ASIC designers to kind of have an approximation for their area, timing, and those type of informations. And I think that's very important for an open source project, hardware project to succeed.
Thank you.
Okay, 2 more questions, and then we're chewing into break here.
Okay, I can Rob from OnChip. So you mentioned about free chips project, but free chips project is not just RTL. Keeping the same question, right? A system on chip requires a lot of analog circuitry. For instance, you are saying that you are releasing the GPIO, but when you are releasing the GPIO, the most important things there are the ESD and all the analog circuitry paths, and then you are breaking the rules with the NDA with the foundry, not just the tools, but also the foundry. Can you comment on that? I mean, it does.
Right. So unfortunately, those are the parts that we were not able to open source because of various contracts that we signed to manufacture the device. So when I said GPIO peripheral device, it was a control to snap into an existing pad library that you would have gotten from a foundry. So that's the border. And the reason why FPGA development kits save you in that regards is because FPGAs mostly have those abstractions within the FPGA, like PHYs and GPIO pad drivers and things like that. So we snap into the same socket there. But I mean, we need to solve this problem as a community to truly enable open source hardware development. Right, it's a tiling interface to the GPIOs and exposes control that would snap into a normal pad driver that you would have gotten from the fact.
Hi, Jansa. This is Tommy from Esperanto Technology. When you look at the purpose, this looks very much like open cores. So what is the difference between you and them? And are you going to address the inconsistent quality?
Yeah, that's a great question. So OpenCore it turns out, is not a nonprofit. It is owned by a for-profit company. So that, unfortunately, that doesn't work for us. The second one is OpenCore I think, did not do a good job holding the bar high for projects. So, people's expectation when they go to some open source repository, I think that was a little bit low. So this nonprofit Free Chips project, we're trying to think about ways to avoid those type of problems.
Okay, thanks, Yunsup.